A few years ago, Mark Zuckerberg became quite infamous for posting a photograph where in the taken in the Facebook offices, and in the background was his workstation, and there was a very obvious piece of sticky tape over the webcam, and that drew an enormous amount of attention. It got posted and reposted, and people talked about it. There were news articles written about it and all kinds of things. And little devices like this had existed before and probably became much more popular. In fact, so much so that my new laptop that I got earlier this year actually has one built in. The manufacturer's building them in now. And the reason is because of issues around webcam security and concerns about that. And Michael Maltsev from Reason Cybersecurity is going to talk to you. He's going to get quite deep into the internals of controlling webcams in the Windows kernel. It's a quite fascinating presentation. So without any further introduction, I'll let Michael take it away.
Thank you very much. Hi everyone, and welcome to the talk about webcam interception and protection in kernel mode in Windows. We'll get back to Mark Zuckerberg and your note. Okay, just a second before I begin, I will make a quick introduction. So I am Michael Maltsev, and I am a developer and a researcher in the company Reason Cybersecurity. Our company was founded in 2012 by Andrew Newman. We are focused on privacy protection, and we have several relevant products. Our flagship product is Reason Antivirus, and this product has a considerable amount of users, and we scan a huge amount of files every day and have quite a bit of insights. For more details, you are more than welcome to come to our booth and get more details. Our outline for this talk will be: we are going to talk about the importance of webcam security. Then we are going to mention different multimedia frameworks that are available in Windows and allow programs to access the webcam. Afterwards, we are going to talk about attack strategies that an attacker can use in order to spy a victim. Then we are going to develop a kernel mode protection driver on Windows to defend ourselves from unwanted camera usage. And finally, we are going to look at existing protection solutions on the market and compare them. Great. So, the importance of webcam security. I assume that every one of you, or almost every one of you, has a laptop or a desktop computer that has a webcam, either built-in or a USB camera, whatever. So this will be relevant for almost every one of you. So you might wonder whether it's even worth talking about. So there are several reasons that can be relevant for you, and I will list three. So first of all, global surveillance, right? I don't need to elaborate. NSA, Snowden, maybe you've heard hacking team, NSO, etc., etc. I won't elaborate. I will just say that there are leaked documents that specifically talked about webcam usage for spying on victims, and there is also source code which uses the camera of those companies and governments, right? So this is a possible way for somebody to misuse your camera. But you might say that you are a regular, boring guy, you're going to work, going back home, you're not an activist or something, this is not relevant for you. So there are other reasons that might be more relevant for you. One other example is stalkerware, right? Stalkerware is a relatively new term which talks about a program which is like an adware with a certificate. Right, you can purchase it, install it on somebody's computer, and take over it, including accessing the camera. Now, it might have legit usage, for example, parental control, but it might also be installed on your computer by somebody, and maybe your friend, your coworker, your spouse, whatever. So you better be aware of it and be ready to protect yourself. And last but not least, an example of a webcam ransom. right? So it happened before, and it probably happens also nowadays. So some random guy over the world can check over your computer, use your camera to capture some unfortunate moment of yours, and ask for a ransom that if it's not going to be paid, this video is going to be published, which is not a pleasant situation to be in, right? And finally, extra food for thought, just like Mark said, right? Mark Zuckerberg, this is a popular photograph, so he knows a thing or two about privacy, so you probably can think about it and make conclusions. Great. So now that I hopefully managed to make a point that this is a topic worth considering, right? So we will dive into the technology, and for beginning, we will list the multimedia frameworks on Windows. So the first multimedia framework which allowed applications to access the camera on Windows was VFW, short for Video for Windows. It was released in 1992, was available on Windows 95 and newer. Nowadays it's obsolete, but there is a compatibility layer which allows old programs to still operate and use the camera. Afterwards, in 1996, the DShow multimedia framework was released. And finally, in 2006, the newest framework up to date, Media Foundation. And if we zoom in and see the flow on the low level, let's assume that we have a program called webcam-capture.exe, right? And it accesses the camera, the webcam on the computer. What happens under the covers that it ends up loading the multimedia framework DLL. It can be Video for Windows, a DShow, or a Media Foundation, right? And finally, this library communicates with the kernel mode driver, which gets the stream from the camera and delivers it to the application. Now, for the scope of our talk, it's not very relevant which multimedia framework is being used, right? So the frameworks are different, they have different compatibilities, different APIs, maybe support different resolutions, but at the low level, it doesn't really matter because the program at the end communicates to the kernel mode driver in the same way. And this is what we're interested in our talk, right? This communication between the user mode world and the kernel mode, because this is what we're going to intercept. So take note. Great. Now, this was the architecture before the introduction of Windows 10 Anniversary Update. Windows 10 Anniversary Update brought with it two innovations to the architecture of webcams on Windows. So the first one is called DShow Bridge. DShow Bridge is basically a proxy which allows applications designed for direct show to use Media Foundation under the covers. It can be enabled or disabled per camera device, and applications can be blacklisted from using it in the registry. Just a side note, there is a launcher main.exe entry in the registry which comes out of the box with Windows, and it was probably created for compatibility reasons with a program of Logitech. So it is handy for testing, right? You can call your program launcher main and it won't use the DShow Bridge. Great. And the second and more interesting innovation is the frame server. The frame server was introduced just like DShow Bridge in Windows 10 Anniversary Update. And it is a server which allows the camera device to be shared between multiple applications. Now, this is in theory. In practice, the sharing compatibility is reserved only for Microsoft services, such as Windows Hello and HoloLens, and maybe some others. So still, if two regular applications try to use a camera device at the same time, the second one will fail. For regular apps, the access is still exclusive. And if we look at the architecture and the low-level flow of a program which accesses the camera by using the frame server, it's going to look like this. So we have the webcam capture.exe program, which tries to access the camera. It ends up loading the frame server client DLL, a library which operates the frame server from user mode. This DLL, this library, ends up communicating with a frame server service via RPC, remote procedure call. And it sends it commands, right? Like start capturing, stop capturing, etc. Once the frame server got the command to start capturing from the camera, it basically does the work just like we've seen before with Media Foundation. So the lower part of this graph, of this flow, is just the same as we've seen several slides before, right? A regular usage of Media Foundation, just that instead of a regular program, we have this service which is part of the operating system. So it starts capturing from the camera and it publishes the frames, it sends the frames to another kernel mode driver which is part of the operating system called the kernel streaming server. So here it is. Right, and finally, the frame server client DLL gets those frames, and they end up being in the control of our program, webcam-capture.exe, and it can display the frames right to the user or save them on disk or whatever. So, as you can see, things got a little bit more complex with the introduction of the frame server. And I believe that you can imagine how more than one program can be in this flow and share the same camera device. Great. A couple of additional facts about the frame server. So it is enabled only for applications which use a Media Foundation, either directly or via the DShow Bridge. It can be disabled in the registry, but it is enabled by default. And fun fact, it is disabled for applications whose path contains the string real sense DCM. Also probably for compatibility with some software of Intel. And also it is handy for testing, right? If you don't want your program to use the frame server, just make sure that the string is in your path and you are good to go. Great. So basically, this is the architecture, and we can proceed and develop a kernel mode kernel driver. But just before we do that, in order to get the full picture, we will see attack strategies and see what are the options of an attacker, so that we will know what to defend against, right? Okay. So let's imagine for a moment that we are the bad guys. We took over a computer, a remote computer, which runs on Windows, and we know that this computer has a webcam, and we want to use this webcam to spy on the victim for our evil needs, right? So what are our options? First option is simple, just start recording. So we have this computer, there are many command line tools, open source code that we can use. We can get started in several minutes, right? So start recording and get the data. So the advantage obviously is that this is very simple and accessible, and Windows doesn't ask questions. The downside is that there is this LED indicator which is available on almost every camera device, and it will expose our activity as an attacker. So the victim can see that there is an unusual LED indicator, and maybe put a tape on the camera or format the computer or whatever. So we don't want this. Another option that we have is what I call stealth. We can take over an existing session of a camera usage. For example, when the victim uses Skype or Chrome or whatever, hijack the session and get the camera recording and send it to us as an attacker. So this is something that can work, and it doesn't expose us via the unusual indicator LED. On the one hand. On the other hand, it has serious drawbacks that we can no longer choose when to record, right? So it might be more difficult for us as an attacker to get more valuable captures that we can use. Also, it is not as easy to implement. Finally, we have a third option, which I call reload mode. So it's similar to the first one, just start recording, right? But with the LED turned off. Now, in theory, it shouldn't be possible, right? You shouldn't be able to use the camera while the LED is not turned on. But in practice, there are several vendors which allow this one way or another. Several vendors have a documented or undocumented option, for example, registry option to turn off the indicator LED. And other vendors implement it in software, so the firmware or the files can be patched, and then the indicator LED can be turned off while the camera still operates. So it's not theoretical. It was done before several times for several vendors. And here is a video which demonstrates one such usage from 2013. Right, let's see it. Audio? Never mind, there are subtitles. Right, so there is a webcam, and here's an indicator LED, and here is a guy who pages the files, replaces them, right? And now there's a webcam. As you can see, the webcam operates, but there is no LED turned on. So it's possible. It was done in 2013. This time, it was done afterwards. It was done via registry for other models. So if you, until this day, hope that you can rely on the indicator LED to see if your camera is being used or not, you can see that it can be bypassed for several models. So take notice. Great. So those are the attack strategies, right? The options of the attacker. Now that we are familiar with this, we are familiar with the architecture, let's try to implement a protection, kernel mode protection driver for Windows, which will defend ourselves from unwanted camera usage. Great. So if we will take on this task and we'll try to find some information on the internet, you will find out that it's mostly undocumented. There is not much information, almost no examples, and there's no something that you can just take and use. But after some research, you will be able to come to the conclusion that the way to go with this is to implement a filter driver to be placed between the kernel mode camera driver and the user mode world. And before we proceed in implementing an actual protection driver, let's implement a simple filter driver which logs the IRPs that pass through to the driver and logs everything so that we'll see the flow and we'll see what's even going on there, right? An IRP is an I/O request packet. It's basically a message which is being sent to the kernel mode device, like, for example, start capturing from the camera, get the next frame, stop capturing, etc. We will soon see several other examples. So it's going to look like this. We have our program, again, our example, webcam-capture.exe, and it sends commands to the camera kernel mode driver, and our filter driver will be placed between the camera kernel mode driver and the user mode world. So we implemented such driver which logs everything, and here are the most interesting and relevant IRPs that come through. So the first two are creating two handles for further usage of the camera. The first one is the kernel streaming filter, and the second one is the kernel streaming pin. So the meaning of these terms are a bit out of scope for this talk, but let's just assume that they are necessary for the operation of the webcam. Afterwards, several commands are being sent of the type case property connection state. Basically, those commands change the state of the camera. The first one is change it to case state acquire. So it's basically acquires control over the camera. Then case state pause, and then case state run. When case state run is being sent, the camera starts streaming, and the application can begin to request frames from the camera, which is what happens next. Here it is. So while the stream is active, the program sends ioctl case read stream commands, and every such command gets the next frame from the camera. And finally, when we decide to stop the stream, the connection state is being changed to case state stop, and the handles are being closed. So this is basically the flow. Now we want to block access to the camera for programs because we don't want other programs to use it. So the simplest option for us is to just block the ioctl case property command when the case state acquire command is being used, right? So we won't allow other programs to acquire access to the camera, and they won't be able to use it and start streaming and get information. And here is how it's going to look, for example, for the built-in Windows 10 camera program, right? Access denied, the user sees an error, and our camera is protected. This is great, but this is too restricting, right? We will probably still want to use a camera when we intend it. For example, when we want to chat with a friend or a coworker or whatever. So one way to implement it is per process selective blocking. So we will want to have a whitelist of programs that we trust and that are using the camera by design. And we will want to block all other programs which are unknown or which aren't supposed to use the camera at all. So before the introduction of the frame saver, it was quite straightforward, right? So this is the flow, as we've already seen. And we can intercept the traffic between the user mode world and the camera driver, and allow access only for programs which are whitelisted. Great. But with the introduction of a frame saver, it became a little bit more complex because if we intercept the same, right, we will think that the process svchost.exe is the one accessing the camera, which is not really true because it is part of the operating system and a part of all of this architecture. So one possible solution for this is to intercept the traffic between the user mode world and the Microsoft kernel streaming server instead. So here, the real program that uses the camera is the one accessing the kernel mode driver. So we will be able to check it against the whitelist and decide. And if we are doing this, we will have to allow access to the frame server and basically to whitelist it because it doesn't make sense to block it since it's part of the OS and the architecture. So this is something that we can do and it works. Great. And now we will review existing protection solutions on the market, how they do it, how it compares to what we've just seen, and maybe how we can bypass them, right? So we reviewed 6 well-known security products on the market, which provide similar functionality to protect the webcam. We don't show the names here, basically because our aim is not to bash the products, right? Spoiler, there will be bypasses. So the aim is not like to say that the protection is not good enough. Our goal is to increase awareness and to show the weak points that can be improved in order to basically improve the protection of our users. Great, so there are 6 products here and 2 columns. One of them is frame server support. If there is no frame server support, it means that every program which accesses the camera through the frame server is being detected as svchost.exe. And the second column is upper filter registered. If there's a tick, that means that there is a registry entry that specifies, that tells the OS to load the protection driver. And we will soon see why it's relevant. Great. So we looked at these products and we took product number 1 and we thought, how can we maybe bypass it, right? So its characteristics is there is frame server support and there is a upper filter which is registered. And we looked at the frame server support, and we, after some experimentation, we noticed that it's being implemented by blocking access to the kernel streaming server, just as we've seen a couple of minutes ago. And in this case, the frame server user mode process, which hosts the service svchost.exe, is probably whitelisted, as we've seen. So we thought, what happens if we inject into it and try to capture from within this process, since it's whitelisted? So here's how it looks, right? Here, an unknown program is being blocked from using the camera, and the svcos.exe process is whitelisted. So we are going to do the following. We are going to inject a DLL into SVC host and capture from there. And here is a video which demonstrates what happens. So for beginning, there is a simple program which tries to capture, and there is some blocking window which we mask the product name. So we cannot capture from the camera, we are being blocked. And now here is the frame server, there's the PID. I took some generic injector from GitHub, right? Nothing sophisticated, and I inject my DLL, which just captures from the camera into this process. So injection successful, and this DLL captures like for 5 seconds and then stops. And you can see that there is an MP4 file, and it just works, right? So bypassed. Okay, we were able to do that, and then I thought maybe there is something even simpler. We have this upper filter registered, so what happens if I just go to the registry and remove it? I expected to get some self-protection, right, to stop me, but surprisingly nothing stopped me from doing it, and it just worked. So after I delete this entry, it's enough to disable and re-enable the webcam device to remove the protection, right? So bypass number 2. Okay, and then I went on to the second product, and it has a little bit different characteristics. There is no frame server support, and there is no upper filter registered in the registry. It's being loaded in runtime by different means. So the upper filter registry is not relevant anymore, but the frame server is not supported. So since it's not supported, every program accesses the camera via the frame server is being reported as svchost.exe. And for this security product, svchost.exe is whitelisted internally since it is part of the operating system. And it turns out that in order to bypass the protection, it's enough for our malware to use the frame server, right? So it's as easy as that. So we went on and checked all the other products, and here is a summary, right? 5 out of 6 products we were able to bypass by one of these 3 methods. Product number 6 wasn't prone to any of those 3, but take note that this product doesn't have walk-in compatibility. It only notifies when the webcam is being used, so it's not very helpful anyway, right? So this is the status. Lessons from this, right? Lesson number 1, if you trust a system service, in our case it is a frame server service, make sure it can be tampered with, right? I would expect a security product to block this injection, but it didn't happen. Lesson number 2, don't forget to apply self-protection for features that can otherwise be disabled. Right? In our case, I could just remove the upper filter entry, which is not okay. And finally, following the OS architecture change, in our case, the frame server, some of the products I was able to bypass them only because they weren't up to date with the architecture changes of Windows 10 anniversary update. Great. So let's conclude. We talked about the importance of webcam security, which is a significant privacy threat. I hope that I convinced you that it is serious and it is real. Then we talked about the webcam-related Windows internals, right, which is not something that you can easily find online. So hopefully this will help other products, maybe you guys, implement better protection for our users. And finally, we've seen the software protection is not perfect. It can be bypassed, and we've seen several weak areas which can be improved. And of course, it's better to use both software protection and hardware protection, right? If you will, a tape or a shutter. And so both are always better. And finally, sharing is caring. So I tell you this information, as I said, so that we can make better products and better protection for our users. And you can find more information in a technical paper, which is in Virus Bulletin blog, called Through the Looking Glass, Webcam Interception and Protection in Kernel Mode. We also have a sample driver for blocking access to the camera, which is on our GitHub page. And also this repository contains slides of this talk. And finally, if you have any questions or ideas or feedback, you can contact me by email or Twitter. I will be glad to answer anything. And that's about it. Thank you very much.